Hi folks, we're going to take a look at page 288, numbers 14 and 15. Okay, do these ones together. So let's start with number 14. They give us this quadratic trigonometric equation, and they want us to solve it on x within 0 to 2 pi inclusive. Okay, so again, here, first thing we do is let's try to use our traditional algebra and take that as far as we can. So here, if I isolate tan squared x, I end up with, well, this plus 1 becomes negative 1 divided by 2. Okay, and then of course the next step would be to take the square root of both sides, but here I can see that I cannot take the square root. So if I wanted to actually show that out, so tan of x would be equal to the positive or negative square root of negative 1/2, which of course has no solution. So that one was nice and quick. So I would say this one falls under the category of do not make up any algebra. You have a squared term equal to a negative number, you know that there's no solution, stop there. Okay, don't try to continue this problem on. Okay, so let's go to number 15. Okay, it's another equation here. So here we have 3 times sine 2x minus 1 equals 0, and it's still x on 0 to pi inclusive. Okay, so as we did before, let's start by isolating the trigonometric expression since we can. So we have sine 2x equals 1/3, which again we recognize as not being related to a special angle, so we're going to have to make estimates. Okay, so we have that 2x is going to be equal to the inverse sine of 1/3. Now that's not necessarily the only answer, perhaps it might not even be an answer, but that's our starting point. Okay, so here we've got inverse sine of 1/3 equals to 0.3398, but how about we just make that as 0.34. Okay, so 2x equals 0.34. Okay, now if I divide this by 2, I see that I will be within my my given domain. So this will be one of our answers once we divide it out by 2. Okay, now here what I'm going to do is I'm going to work with the fact that I know that it's sine of 2x. Okay, so I'm going to find my other values for 2x, and then I'll divide by 2 afterwards. Now this is where we have to understand that sine 2x is a compressed sine function. Okay, so within 0 to 2 pi, we're actually going to be going through 2 cycles around the Cartesian plane. So here we have one of our answers in the first quadrant. Okay, we know that there's going to be another answer in the second quadrant. Okay, so we also have that 2x can be equal to pi minus 0.34. Okay, so here we've got 0.14 minus 0.34. Okay, really should have done that in my head, but just to be quick and fast. Okay, so that will result in another answer, but because we're dealing with, remember, we're going to be dividing these by 2. Okay, so we can actually get 2 more answers in the second turn around. And how do we get those answers in that second turn around? Well, it's just a matter of adding 2 pi to our first answer and then adding 2 pi to the second answer. So we also have 2x equals 0.34 plus 2 pi, or I'll use 6.28. Okay, so here, what do we have? 6.28 plus 0.34 equals 6.62. And then, of course, we'll also have 2x equals 2.8 plus 2 pi. Okay, oh, should have used 6.28. I'll use that here. So here we have 2.8 plus 6.28, and that gives us 9.08. Okay, and so now I notice that these two numbers don't lie within 2 pi, but remember, we're going to be dividing by 2. So let's find our actual answers. So here we have x is equal to 0.34 divided by 2 will be 0.17. Okay, there's one answer. Here we've got x, 2.8 divided by 2 will be 1.4. Okay, here we've got 6.62 divided by 2, so that'll be 3.31. Notice, once I've divided by 2, it is within 0 to 2 pi, which remember was our given domain. And lastly, we have 9.08, so that will be 4.54. Okay, which again also lies between 0 and 2 pi. Now, had I moved on and added another 2 pi to this first solution, we would have seen that we would have been outside of the range. Okay, so there we go. Here's our